Well, welcome to Austin Community College's Resistors in Series and Parallel Lab. So I hope you have your handout handy, as we like to say, kind of in hand so you can follow along with what we're doing. You're going to take the data directly from this video as we proceed with the lab. I'm just going to be your hands and so forth here working the material for you, and so we're going to begin. I just want to explain a couple of things. These over here are capacitors. We're not using them in this particular lab. This is a very large resistor. I think it's a 25 watt 1 ohm non-inductive. We have a light bulb, and these are what we're interested in today. These, I've labeled them, these are resistors, R1, R2, and R3. And we're going to put them in series parallel. We're going to find out what the equivalent resistance is of each setup. We're also going to get voltages and currents, and you're going to compare our experimental values with the calculated values. And we're going to begin with actually getting the values of these three resistors. Now, the three resistors we have are nominal. They're plus or minus 5% or so. So what we're going to use this multimeter, and we're going to use it first as an ohm meter, have nothing connected to the circuit, and we're going to get the actual values we're going to use. Now there is a place to put in your lab for R1, 2, and 3 the values that we get. We've pre-recorded in another video how the meter works and the functions of using the multimeter, and we might insert that here. So the first thing we're going to do is show you a little bit about the multimeter. It does multiple things. It will do with the sine wave, or over the V is voltage AC. That's the symbol for voltage DC, which we're going to use. It's the horizontal solid with a dotted horizontal below it with the V. We have an ohm meter that we're going to use right now. Continuity tester, it does diodes, capacitors, current in AC, current in DC, and also it can measure frequency. Okay, so we are going to start out with ohms, which is this right here. So we turn our meter onto ohms. I'm going to grab two wires. Nothing's connected to the circuit. I'm going to put these on here. And we're going to come over and we're going to measure, first let's measure R1. Now one thing about resistors, it doesn't matter polarity. It doesn't matter which way the current or voltage or the current goes through, or which is the high potential, low potential side. So we'll just randomly stick these on, and let's see if we can get our meter to, oh, I'm in the wrong button here. Okay, so I'm going to put in here, we're going to measure our ohms. So the nominal 320 in the lab you need to write down is this value, which I'm seeing is 322.2 ohms for R1. Let's move to R2. We're here to R2. And boy, that one is the nominal value. That's pretty neat. And we're going to move on here to R3. And we want to record this value for the value we're going to use to calculate is not 200, it's 206.6. Now in the lab, what it says to do now is we want to make a series circuit using R1, 2, and 3. Now off to the side, we're going to put up here a still shot of our power supply. Since it's really not doing much and it would be hard to get in the video, we're going to just put a still shot in of that. We're at 15 volts, and the two wires I'm holding here are 15 volts coming from our power supply, which is right here. This is the high side of 15 volts, high potential and low potential. So we want to put that over here, and first let's wire our circuit. Now what I'm going to do is I'm going to probably come into R3. This is the power supply wire, the high potential 15 volts. And then we're going to pick some little red wires, and we're going to come out of R3 and into R1. We're going to string them back to back, just like Christmas tree lights or something like that, just one after the other. So if you can follow the circuit, coming in R3, into R2, out of R2, into R1, and then we come back to the power supply. So that is the completed operating circuit that we have here. And but we're going to unplug this, and I want to get the equivalent resistance of this series circuit. So I'm going to put, this is my ohm meter. We're just going to measure it. There's no power supply hooked up. I'm going to measure the equivalent resistance in ohms. This is the value, and that is procedure 1, step 2, this value. Now it says we're going to wire up a parallel circuit and get the equivalent value, so we're going to undo this. Parallel circuit is different. We can pick one side or the other. I'm going to pick this to be at the high potential, 15 volts. And note what we've done here is we've just hooked all these ends up together. It's like you could just put a wire directly across, only these are loops, but they're just totally connected together like that, like if we had a copper bar across here. We're going to do the same thing to the other side. And if you look at your diagram, what I'm doing here should make sense. Okay, so we have our two bus bar like things. We have high side and a low potential. Now here's the neat thing with our power supply, or even our ohm meter. Let's use our ohm meter because we want to get the equivalent resistance. It doesn't matter where this is put, here or here. It really doesn't matter because it's just all at the same potential if we had power to it. So this is what we've got. This is our value in ohms, and I'll show you what I mean. We could put them here. We could put it here. Okay? So a lot of times I will just put this closest to me because it's convenient. Okay, and that was procedure 3. We got the equivalent resistance in parallel. So now we're going to undo our circuit. We're going to create the circuit that we're going to operate with power. Our power is going to come in here. We're going to do our series again. So we're going to come out of the R3 into R2, out of R2 into R1, just straight through, and then this one will go back to the power supply. So we're going to hook the power supply up. These two wires have 15 volts across them. I'm going to adjust it in just a second, but that's our high potential going through all the way back to home to the power supply. Now let's check, make sure it's 15 volts. I need to be in volts, my mistake, volts DC. We're pretty close. Let me crank it up just a bit. As long as we get it pretty close. That looks like it, 15.01 volts DC. Now we're actually going to start taking some of our measurements. We start out with voltage across the power supply and then voltage across the resistors. I'm going to start out with the power supply. So I'm going to reach over here off camera and I'm going to plug it directly into the power supply, and this is our voltage from the power supply we're using. We might post another still image of the power supply, but it's just 15 volts DC. Unplug that. Now let's measure. The easy to measure voltages we're going to measure in parallel across, and so it's very easy. We just put, this is R3, we're just going to put it across R3. This is our value for voltage across R3. We're going to measure across R2. Note again, we're measuring the voltmeter is in series. Now let's switch this around. Let's make it pretty. Now that negative doesn't really matter. It's a direction through the meter. But here's value across R2. And now we're going to get the value across R1, voltage DC. Okay, so that was procedure 2, part 2. Now we're going to go to Procedure 2, Part 3. And now we're going to measure currents. In currents, we put the meter in series with the thing. So what we're going to do is we're going to break the circuit at each point and put the meter in it. So what we're going to do is we want to measure, let's measure R3. We're coming in here. This is the power supply. This is our 15 volts coming through here. We're going to break it right after it leaves this resistor 1. So what I'm going to do is I'm going to send it, instead of going directly to R2, I'm going to send it through the meter. In fact, this might be easier to see if I use a short wire. So we're going to send this here. Oh, I'm really bad about that. I got to be in amps DC. There we go. So that is our current. I'm going to put the circuit back. You have your value, record your value. And I'm going to go break it here after the R2. And break it here and send it through the meter. It'll reach. Going to be a tight squeeze. And there is our value at that point, at that juncture. Okay, so you want to record that. I'm going to put this back together. We're going to proceed on. Just left here, we're going to send through the meter first to here. You can get a current. And there's your value. You might ask yourself if it makes sense at this point, your values that you're getting, having looked at your equations for this particular circuit. And then the last thing we're going to do, we're going to put this thing back together like this. And we're going to measure current at the battery or the power supply. So I'm going to break the power. I'll need a longer wire for this. Break the power, and instead of going directly into the power supply, back in, I'm going to just send it, bypass it through the meter to the power supply. So that's that value. Okay, that completes Procedure 2 of this lab. Okay, we are going to move on and do Procedure 3 in the lab. We're first going to set up our parallel circuit, just kind of like we did before when we measured the ohms or the resistance. I'm going to set it up. Okay, and remember, we can put our high potential on any 3 of these and our low potential on any 3 of those. Okay, so we've got our equivalent parallel resistance. Now we're going to power it. This is our 15 volts off camera. We might put that up again to just show you the power supply. But I'm going to start up here so they're kind of out of my way. So I'm going to put them on the top or away from me. These 2 wires from our power supply, 15 volts potential. And the first thing we're going to do is measure voltages. So our voltages are pretty easy. We put our meter in voltage DC. We just simply measure across the power supply in each resistor because it's a parallel thing. So we're going to do R3. And there is our voltage. We're going to crank it back up to exactly 15, or pretty close to there's 15. We're going to measure across R2. Note what's happening here. We're going to measure across R1. And then ask yourself if that makes sense. If these are all connected up, these are all connected up, that we have kind of the same potential difference across the 3. And then we're going to measure again the power supply off camera and plugging it directly into the power supply. There we go. We're only, this digit here, this hundredths of a volt, we're going to kind of ignore. We're looking at maybe getting it close to this 1/10 of a volt. The meter is just really accurate.
Okay, so we've done that. We've recorded it. Now we're going to go to procedure 3, part 3, and we're going to get the currents. Now here's the part that kind of confuses students, but it's a good thing to learn how to wire. Remember that we're going to have to be in current DC. I'm going to try and do this with short wires if I can, so you can see it in camera, all the wires. So we've got power coming into here, and it has a choice. It can go through R1, R2, or R3. It may vary depending on the resistance. That's kind of what the lab is about, the current that I'm talking about specifically. So we're going to put one of these wires in common. There's our amp, and here's what we're going to do. We're going to break the circuit at each point and send it through the meter to that spot. So let's start with R3. How are we going to break the circuit? Well, we're going to pull that wire out. That circuit's broken right there. So to connect it back, we just are going to send it through the meter to that point. Well, let me switch these out just so we can get a positive value. Back to that point, and that is the current through resistor 3 right there. Okay, so we want to record that value. I'm going to put the circuit back the way it was. And on this one, it looks kind of hard to decide how to break that circuit, but basically all this comes in here. We're just going to take the whole thing out. We're just going to divert it through the meter back to there. And this is the value of current going through R2. I'm going to reverse what I did and do the same thing up here. I'm going to completely break the circuit. I'm just going to divert it through the meter, send it through the meter to there, and this is our current through R1. We have one more to go. So I'm going to unplug this, stick this back on. Now, off camera, I'm going to send this through. I'm going to unplug the power supply, and we're just going to divert it through the meter to the power supply. So this was the one, the low potential in the power supply. I'm going to come in here, and I'm going to go over to the meter. I think we probably want to be here, and over to the meter. So this is that value. Let's see, get the wire out of the way. Is that correct? Hang on a second. Yes, that's correct. So there's that value. Okay, well that is all the data for this particular lab for resistors in series and parallel. You want to go through, make sure you do all your calculations. You're going to compare our experimental that we did here today to your calculated values using these resistors and the voltage. And that completes the series and parallel resistor lab.